This is problem number 49. It is another deductible problem and an expected value problem, but in this case our loss values are discrete and not continuous, so there's no integration to be concerned with. We're given a deductible of 2, a probability of loss at 5%, and then given that there was a loss, the probability of the amount of that loss is given by this expression, k over n, where k is some constant that we're going to have to solve for, and n is the amount of the loss. So I've also written out this expression here. I've called it n sub d. This is the amount of payment where we apply the deductible to the different loss amounts. So if there's a loss amount of 1 or 2, we apply the deductible and we don't pay anything. And then if there's a loss amount of 3, 4, or 5, we apply the deductible and pay 2 less. So the first thing we should be doing here is we should solve for the constant k, and we're going to do that using the law of total probability. So we've got P, probability of our loss amount is equal to k over the amount of loss, and there are 5 different possible loss amounts. And we get to set that equal to 1 by way of the law of total probability, right? There's 5 possible loss amounts, 5 associated probabilities. We sum them up and we get a total of 1. So let's factor out the k. And then rewrite our fractions here. Okay, and using the calculator, we get k times 137 over 60 is equal to 1, which tells us that the value of k is just about 0.438. So step 1, solve for the constant of proportionality using the law of total probability and our expression for the probability of the amount of loss. Step 2, use on the expected value with the amount of payment. So that's going to be very similar. We have the expected value of the amount of payment given that there was a loss will be equal to the constant of proportionality that we just found. And then we'll take this chain of probabilities and multiply them by these amounts of payment. So we have 0 times 1, and you can see why a deductible was applied here. The probability of a loss amount of 1 is guaranteed. It's 100%. And of a loss amount of 2, it's a 50% chance. So our deductible eliminates those high probability losses, 0 times 1, 0 times 1/2, and reduces the amount we have to pay. So amount of payment times probability of loss plus amount of payment times probability of loss plus amount of payment times probability of loss. And churning that through the calculator, we get 0.6278. Now, last but not least, these were conditional, right? There was only a 5% chance that the loss was going to take place to begin with. So what we're really in is a situation right here where 95% of the time we pay 0 plus 5% of the time we pay this 0.6278. And that comes out to 0.03139, which means we select answer choice A.